All right, today we're going to talk about solving quadratic inequalities. You can do this with algebra using, factoring sometimes. You can do this graphically or also using a table. We don't do the tables much today here, but let's jump right into it here, how to solve a quadratic inequality algebraically. So typically you'll have something like this right here. And what you want to do first is figure out where the zeros are or where the, like what x is equal to. So we're going to solve something real similar to this. We'll do 4x squared minus 36x equals 0. Notice it's not greater than. We're going to do equals 0. Then we're going to figure out what values of x make that true right there. To do this here, we solve by factoring. We can factor out a 4x right there, and if we do that, we'll be left with x minus 9. Okay, and then from there, you set your factors equal to 0. 4x equals 0, or x minus 9 equals 0. And then divide, x is equal to 0, add, x is equal to 9 right there. Those are your two x-intercepts. Now you would get the same x values right here, but since we have this inequality sign here, that kind of messes things up here, and it's kind of hard to go back and tell, okay, where is, x, I guess supposed to be, is it supposed to be between, 0 and 9, or greater than 9, less than 9, greater than 0, less than 0. So we're going to use those critical values. We call those the critical values, x equals 0 and x equals 9. And then we're going to put that on a number line. So I'm just going to do a number line over here. I'm going to sketch 0 and sketch 9. And then what I'm going to do is pick different numbers in the different regions here. You really have 3 regions. And then when I plug it into the original equation back here, does it make a true or false statement? If it makes a true statement, we shade that region. If it doesn't make a true statement, we don't shade that region. So for example here, if I want to test this region here to the left of 0, I need a number less than 0. So I'm going to try out -1 right there. And then we'll just go and see what happens here. So we have 4 times -1. And actually, let me write it up here, kind of above the section. 4 times -1 squared, and then minus 36, whoops, and then times -1. All right, first of all, 1 squared or -1 squared is positive 4. So, or positive 1, that'll be positive 4 right there. And then you'll get negative times a negative would be positive 36. So that'll come out to, I guess, 40. And 40 is absolutely greater than 0. So since that is a true statement there, then we're going to shade this region. Okay. All right, next we need a number to test out between 0 and 9. I try to keep the numbers small, so I'm going to test out 1. We're going to see if 1 works out right here. So, and that's positive 1, by the way. So we'll go 4 and then times 1 squared, and then minus 36, I guess, times 1. Okay, and then when we do that, apparently we'll get 4 and then minus 36. And then remember, we're trying to see, is that greater than 0? Obviously, 4 minus 36, that's negative 32. That's definitely not greater than 0. So we do not shade this middle region. Okay, and then after that, we need to go test a number here past 9. I'm going to go do, I guess, 10, and then see if that works. I guess, sometimes people go label it on the number line what they're testing out. You don't, I guess, need to, but so let's go ahead and do that. Let's see here. I'll do it in different colors since I'm crammed in here. So that'd be 4 times 10 squared, I guess, and then minus 3, or I'm sorry, 36 times 10. And is that greater than 0? Kind of running out of room there. Okay, 10 squared is 100, so 4 times that will be 400. And then this will be minus 360 right there at the end. And then we got to see, okay, is that greater than 0? Well, that's 40, and 40 definitely is greater than 0. So then we shade this region as well. Okay, so then the way we write our answers is we write, kind of like from Unit 1, we write the domains of these here. So we're going to say, okay, it's everything from negative infinity all the way up to 0. Okay, And then since we had a greater than and not a greater than or equal to, we're going to put parentheses around both of those. And then the second piece is going to be starting back up here at 9. So really you need open dots there, I guess. So starting up here at 9 and then going towards infinity right there. So it's kind of a lot of work here on these. So let me recap what we did. We factored, we solved by factoring, we got these things called critical values right there, x equals 0 and x equals 9. We make our own number line with x equals 0 and x equals 9. And then we try out test values. We go try out numbers in the regions to figure out if we shade in that region or not. Obviously, we'll have one more example here kind of going through that process. So we'll see that same thing again. So let's try it out here. Example 2, solve this inequality here. It's less than or equal to 0. So we'll see how that changes. So let's see here. So first of all, we'll factor the left-hand side. And we need to factor this here. I guess we need to set it equal to regular 0 first and then factor. So I need numbers that multiply to -4 that add up to +3. So you could do +4 and -1. Then you're going to set your different factors. X plus 4 equal to 0. X minus 1 equal to 0. So therefore x equals -4 and x equals +1. Noticing factoring here is a big part of this unit here. So you need to make sure you get that down. And then I guess we'll make a number line here. We're going to put a point at -4 and then a point over here at 1, I guess. And then we got to go and test all the different regions to see where the solution is. Is it going to be here, over here on the left? Is it going to be in the middle? Is it going to be on the right? We're not sure. So pick a number in the different test regions. So I'll try out -5 over here on the far left first and see if that works out when I plug it back into the original equation. So I'll kind of go over here. So that would be x squared. So that would be -5 squared plus 3 times -5 and then -4. And we're going to see is that less than or equal to 0. So that would be +25. That'd be -15 and then -4 right there. That looks like that'll be a positive number there. So what is that? 10 minus 4. I guess that'll be 6. And 6 is definitely not less than or equal to 0 right there. So you do not shade that left region. Okay, let's go try a different test value here. Something between -4 and 1. I like it when they give us ones like these here because I want to try out 0 right there. 0 is one of the easiest numbers to plug in. So now I'm going to go as 0 squared plus 3 times 0 minus 4. Is that less than or equal to 0? And once you simplify it down, that's -4 less than or equal to 0. That is a true statement. So you do shade this region. By the way, as far as is it a closed dot or open dot, look at that symbol right there. That's less than or equal to. So then you'll shade in between. Alright, and then after that, now we need to go and test this far right region right here. So choose a number bigger than 1 here. So I guess we'll do 2. And we'll go and plug that in. So 2 squared plus 3 times 2. And then -4, is that less than or equal to 0? I guess that'll be 4 plus 6 minus 4. And notice that you'll get 10 minus 4, so that'd be basically 6. Is 6 less than or equal to 0? That is definitely not true there, so you do not shade that last region. And then the way you write your solutions, you write it, it's going from -4 to +1. And then since there were closed dots there, we're going to put brackets. And that is it there on that section. All right. Now, before we talk about doing these other types of solving with graphing here, we're just going to recap graphing, I guess, inequalities here using shading and everything. So we're just going to graph the following equations or inequalities here. So this solving part actually comes down here in a minute. It's kind of I guess a typo. So that'll be solving down there. So anyways, these are just graphing here So it kind of works out similar to just regular graphing here. We need to figure out, I guess, kind of what this graph looks like here. So you can use a graphing calculator on this one. You can also factor to figure out where your zeros are going to be. So that might be something kind of helpful on this. Like for example here, if you have negative x squared minus 4x, then you're trying to figure out your x-intercepts, you could factor out, first of all, I guess, negative x, and then you'd be left with x plus 4. And then equals 0, so that means negative x equals 0, and then positive x, x plus 4 equals 0, so then that'd be x equals negative 4. So if you go put a point here at negative 4 and then 0, then you can kind of go and get the rest, I guess, of your graph. I think it's going to look something sort of like this right here once you do that. And you can go get all those points from your graphing calculator, or you'd have to make a table. Okay, so anyways, the graph kind of looks like this. Since it is a less than sign, we're going to do like a little dotted line, kind of like this here. All right, and then as far as which way do you shade here, this is y is less than. So we're going to shade everything less than this curve right here. So all of this region here. So any point in that region there would be a solution to a two-variable inequality here. So like for example, a point right there well, it doesn't even need to be on the x-axis there. So like negative 2 comma 1 is a solution. A point not in that region, so like for example 2 comma 2 is not a solution. And then points directly on a dotted line like this right here is not a solution because it's on a dotted line, and points on solid lines are. So that is that there. Let's go and see what's going on here with this one. I think the graph is going to be super pretty here. I'm going to find the x-intercepts, kind of like that trick I just used before. And actually, we already kind of factored something real similar to this. This will be x plus 4, and then x minus 1 equals 0. So that means x plus 4 equals 0, and then x minus 1 equals 0. That means x equals negative 4 and x equals positive 1. Really, those are the points that are really nice when you're graphing these. And then I guess we'll have a point down here at negative 4. So something kind of looking like this here. And I'm just kind of doing a rough sketch right there. Just getting a couple points there. I don't think your vertex is going to be the nicest of points here on this, so don't worry too much there about that, I guess. So there's your graph. It's a solid line there because it's equal to. And then since it's greater than, that means you shade everything that's above your curve. So it'll be all of this region right here. And once again, any point in this region right here, this is a solution. Any point not in that region is not a solution. And then any point directly on a line right there is a solution. And that's how you graph two-variable inequalities right there. Okay, so now we're going to switch back to solving here. So this actually kind of ties with this first section here. So solving using graphing. This is actually my preferred method as far as solving with graphing here. So what we do is we're going to go and graph this equation, and then we're going to figure out when is it less than or equal to 0. So we got to think back to previous unit here, this plus 4. It's in vertex form, right? So that plus 4 moves our vertex to the left 4, and then down 2 units, kind of like right there. You got a vertical compression of 1/2. So when you go over 1, you're going to only go up over 1/2, and then when you go over 2, you go up 2. So a little bit off our graph, kind of like right there. And I think this x-intercept here should be at x equals 6. But anyways, if you're having trouble getting that, use your graphing calculator or make a table to get those points. So anyways, we will go and finish graphing that there. And then what the question here is asking is, when is this graph less than the y value? Remember, this is kind of like a y value. When is this thing less than the y value of 0? So if we go and graph a line of y equals 0, here's what that looks like. Which obviously, yes, that's the x-axis, but the line y equals 0 is right here. And then you're asking, when is the graph less than or equal to 0? It's going to basically be this part of your graph here. This is when the y values are less than 0. So that is what this is asking. I would even write that down. This is asking when, I guess I should say, are the y values less than 0? When are the y values less than 0? So that happens once again in this region right here. That's y values less than 0. So we usually write the x values that those happen between here. So that's why I wrote x is equal to, it's actually -6. So that's at -6 and then all the way up to x equals +2. Right, or actually -2 there, I'm sorry. And then we're going to write that as an interval. So we'll say from -6 to -2, and then since it's the equal to, we'll put brackets with that. So let me recap that again. I know it's kind of wordy there, and so this is asking, when is the equation less than 0? Where are the y values less than 0? Right here. So if you graph the equation, the y values are less than 0 right here below the graph, cutting off at -6 and -2. Let's try another example. Let's see, this one here. Okay, so this one is actually the same exact graph, except it's asking, when is it greater than 0? So I'm going to go ahead and sketch that. That was, once again, left 4, down 2, over 1, up a half, over 2, up 2. And then once again, this is cutting off at x equals -6, and then x equals -2. Okay, and then we can get our graphs. Okay, so when this is asking, when are the y values above 0? When are the y values above 0? So that would be starting here at -2 and everything to the right of it, or starting here at -6 and everything to the left of it here. So there's two different pieces of the graph right here. So we write that as an interval here. We'll say from -infinity all the way up to the x value of -6 with a bracket. And then it picks back up at 2. So you start back at 2 and then you go to +infinity. And that is how you do those types of problems. So really they come down to graphing, figuring out your x-intercepts. Hopefully they give you nice x-intercepts. So figure out your x-intercepts, and then figuring out, is the graph above or below 0 based off of this symbol here. This is saying, when is the graph above 0? If it's less than or equal to 0, it's saying, when is the graph below 0? And that's how you do those right there. Okay, and then I think we're going to do that same idea here with a word problem here, and we can solve it with whatever method that we learn. We can use the graphs, or we can do a number line and use test values. And honestly, I prefer the graphing a little bit more, so that's probably the way I'm going to show it here. So anyways, a restaurant delivers meals to a local business when they have evening meetings. The function -5x squared plus 50x models the restaurant's profit y in dollars for an order of meals. How many meals must be in order for the restaurant to make a profit of at least 105 right there? So the first thing I'm going to do here is write out the equation. And then if I need to be at least 105, that means I need to be greater than or equal to 105. And notice how I wrote the inequality and that total amount on the right side. That usually will make it a little bit better if you do that. Okay, but to solve with graphing or to solve using test values, you need it equal to 0. just like pretty much everything we've done with this unit here. So I'm going to subtract over that 105. That'll be minus 105 right there, and then I guess greater than or equal to 0. Okay. From here, I guess I need to factor. So I'm going to factor out a negative 5. And if I factor out negative 5, that'll be left over with x squared, I guess minus 50x. And then, or not minus 50x, let's try minus 10x. Sorry, it's a little late here. And then that'll be, factoring out a negative, that'll be positive, I guess 21. Okay, and then from there I can factor everything inside the parentheses right here. So this will be, x minus 7 and then x minus 3. Which basically means your x-intercepts of this are at x equals positive 7 and x equals positive 3. Okay, so then I'm going to just sketch a graph. It really doesn't need to be that precise. I just need a sketch here. So I need x-intercepts at 3 and 7. And if you go back and look at the original graph, it had a negative out in front. So we're going to make it open up with a maximum. I don't know how high it needs to go. It doesn't really matter. Really what matters are these x values here. X equals 3 and x equals 7. And if you go back here and look at this equation right here, yes, everything below was to get the x-intercepts, but if you go look at that highlighted equation, it was asking when is the graph greater than or equal to 0. So that means above 0 as far as the y values right there. So that is between 3 and 7. And that is how you write your answer. You say between the values of 3 and 7 right there. And I guess what was that, in meals or something like that? How many meals? Yeah, so between 3 and 7 meals right there. And that's how you do a problem like that there. And I believe that is it for this lesson here.